Hello, and welcome to the Access Journal webinar series. Thank you for taking time to join us today. We're excited to continue this monthly webinar series, which features the latest research published in our journals. Before we begin, I'd like to mention that questions can be entered in the questions section, and we will address them at the end of the presentation. The webinar will be recorded, and the recording will be emailed to all attendees at the end of the session. Now I'm happy to introduce our moderator for today, Dr. David Horvath. Dr. Horvath is a research plant physiologist for the USDA ARS in Fargo, North Dakota. He has spent the last 30 years with the USDA working on genomics and molecular biology of dormancy and invasive weeds such as leafy spurge and Canada thistle, freezing tolerance in oilseed crops, and most recently, understanding and mitigating yield loss in crops caused by weeds. David?
Thank you, Emily. And thank you all for taking the time to join us here today. As Emily mentioned, please enter any questions in the Q&A section, and we will address them at the end of this presentation. So, without further ado, I'd like to introduce today's speaker, Skye Brugler. Skye is a research associate at South Dakota State University, currently pursuing a PhD with a focus on greenhouse gas emissions and climate-smart agriculture. During her time at South Dakota State University, she has collaborated with an interdisciplinary team of researchers studying responsible innovation in agriculture. Skye is passionate about advancing sustainable agricultural practices as well as precision agricultural technologies. Today, Skye will speak on precision agriculture adoption. Precision agriculture aims to enhance resource use efficiency and sustainability. However, it faces adoption barriers such as financial constraints, farmer hesitancy towards decision support systems, and concerns about data ownership and the need for a specifically trained workforce. Skye will explore these challenges. Her associated article was published as part of a special section in the most recent issue of Agronomy Journal. Skye, welcome, and the floor is yours.
Awesome, thank you so much, Dr. Horvath. So let me just move this over here. So like Dr. Horvath said, this was a forum paper that we published with the societies in that magazine, and I'm really excited to share it with you today. So precision agriculture is really important for addressing future challenges in agriculture that will be exacerbated by climate change, as well as challenges that we haven't seen yet. And precision agriculture is a wide variety of different technologies, and they can essentially improve resource efficiency and increase productivity and reduce our environmental impact. And they do this with data-driven strategies such as site-specific temporal and spatial data and support management choices for our farmers. So some of the precision agriculture tools that I have listed here include drones, variable rate technologies, and yield monitors, but I'm sure that you can think of a wide variety of other technologies that encompass precision agriculture. One of these tools is decision support systems. So decision support systems are a user interface that has a model and that can help make complex and site-specific recommendations. That's especially important in agriculture because there are so many possible optimal decisions that can be made for management practices and things like that. So essentially, a decision support system would, if you are trying to optimize your irrigation schedule, for example, in a specific field, you could take all this information such as your soil type, your weather, your canal network information, crop type, and planted acreage. You could put all of that together into this decision support system as a user interface, and that can result in an optimal irrigation schedule for that field. And I want to kind of touch briefly on these 4 big steps. And there are a lot of nuances to these steps, but just to briefly touch on each of these steps for a decision support system is first, the data needs to be collected. So that would be like drone imagery data, satellite imagery data. You could also have soil or plant sensors in the field. Yield monitor data is important, as well as climate information and management information as well. Then this data is processed, and we will definitely talk more about the processing part in a little bit, but it is processed in three main ways. There are process-based models, empirical models, and now becoming more prevalent are machine learning and AI models. And then from this processing, you have your results. So that comes from the identifying the decisions and shaping management strategies from the data that's collected and processed. And that can look like fertilizer application, irrigation management, pest management, things like that. And these results can help to shape the management strategies that are used in a field. And over time, that can help us to increase productivity and reduce our environmental impact for a field. So you are probably very familiar already with process-based models and empirical models. A process-based model is a model that uses the physical, chemical, and biological processes in a system and our understanding of that, putting that into a mathematical model to help us make recommendations. So a really good example of a process-based model is yield goal times 1.2 minus nitrogen credits to provide a recommendation for the amount of nitrogen that you should put on your field. The yield goal times 1.2 is based on our understanding of the system in which yield is linearly related to nitrogen. Empirical models are a statistical rule-based model. And I think a really good example of an empirical model is the North Dakota wheat nitrogen calculator. So for example, you have these different variables that you input into that statistical model, such as the productivity, the management, the region in which you have your field, and these variables go into that statistical rule-based model, and that can generate the recommendation for you. So you might be very familiar already with those process-based and empirical models, but you might not be as familiar with artificial intelligence and machine learning models. And there are a lot of pros to using these models, and there are some cons as well. First off, though, artificial intelligence and machine learning are under the same umbrella of a concept, but they are not the same thing. So artificial intelligence is a task that a computer can do that was originally only able to be done by a human. So what I mean by that is something like a navigation system in your GPS. It can take you from point A to point B. Navigation was a task initially only able to be done by humans and is now able to be done by your computer. But machine learning, on the other hand, is a little bit different than artificial intelligence, and that is because it can update itself. So machine learning can identify new and complex patterns through this updating without human intervention. And it essentially does this through a series of training and testing in which we give it inputs. We call that ground truth inputs. And these inputs it uses to create a model. And from this model, it makes predictions, and then it tests its predictions based on that model that it made. And it goes back and forth between the training and testing until it can determine the lowest error for that algorithm that's possible. And this is a really big, important pro for machine learning and artificial intelligence models in agriculture because we are starting to get massive amounts of data. And with this massive amounts of data and these advanced algorithms with machine learning, we can use machine learning to identify new and complex patterns from the data that we are giving the model. A really good example of this are vegetative indices such as NDVI, RDVI, GCI, but there are a lot of vegetative indices as well as soil indices and water indices. And we can get imagery data from a drone or a satellite, calculate these indices based on the bands that we extract, and then feed them to a machine learning model. And they can help us to predict yield or different stressors in the field at different periods of time. And that can really help to determine management strategies for a farmer. So that's a really big pro of machine learning and artificial intelligence in farming, but a con is that there is a subset of machine learning called deep learning. And don't get me wrong, deep learning is also really important and can give us even more computing power, use even more data than conventional machine learning, and it can be a really powerful tool. But deep learning is also considered a black box. And that essentially just means that it has very low explainability. So kind of to illustrate this, in this slide, you can see that this is kind of how a deep learning system is set up. So you have that input layer, and then it goes through hidden layers, and then you get an output. And these hidden layers are not necessarily just these two hidden layers like you can see on the screen. Oftentimes it's a lot of hidden layers. And the really cool thing about deep learning is that it's supposed to be mimicking the way that dendrites work in the human brain and the synapses that are firing or not firing based on connections that we make when we're thinking. And so that's why it can be very powerful. But also, because of that, it's very difficult to explain how the inputs that we provide this model generate those recommendations for that output. And so that low explainability can be extremely frustrating to a farmer, especially because if they're going to be making recommendations based on this model, they want to know why the recommendation is the way that it is. So essentially going from the point in which data is collected until we can increase our productivity and reduce our environmental impact in a specific field goes through these 4 steps. Machine learning and AI models are often part of that model processing part, and we see that there are barriers to adoption often in the middle here. So with the processing of the models and the shaping of the management decisions. And so that's what the rest of this presentation is going to be talking about today. So adoption of precision agriculture tools is really variable. There are some precision agriculture technologies that are more prevalent than others, such as yield monitors are more prevalent in agriculture than variable rate applications. And this suggests that there are barriers to using this technology. And we want to be able to identify these barriers as well as address these barriers now in precision agriculture tools that we currently have so that we can address and identify these barriers for decision support systems using machine learning in the future. So some important barriers to long-term adoption were identified in a survey. So agriculture retailers were given a survey every other year since the mid-1990s to provide insights about how their producer clients and their attitudes on precision agriculture technology. I'm going to be referring to these 4 barriers that were discussed in Erickson and Lowenberg de Boer 2022 publication. So that is economic limitations, trust concerns, data privacy concerns, and trained workforce availability. So first off, financial constraints. So we know that small farms have a more difficult time making a return on investment, and so I've really focused on small farms when it comes to these financial constraints. And we know that precision agriculture tools can be extremely expensive, which can be very difficult for farmers to make that decision, especially if they're not entirely certain that it's going to increase their productivity. So the wrong decisions can be economically devastating for a farmer. Specifically, they might not be able to make land payments, pay for inputs, personal expenses, things like that. So these are very serious things that they are considering. And that can really deter the farmer from taking these economic chances if they're not entirely sure of the profitability of this tool or where that tool really fits into their operation. Additionally, it's really important when we're focusing on small farms to identify whether or not this is a financial constraint issue or if it's just a lack of variability on that small farm. And the reason for that is because a lack of small farm data could really create a data bias when it comes to precision agriculture tools, especially with machine learning and AI models. And so this is a barrier that we really need to identify and address so that we can ensure that there is reduced bias in the future precision agriculture tools that we are creating. Additionally, Ashworth 2018 discussed the cost of equipment per hectare and how that decreases with increasing farm size. And so I have a small brief example to kind of illustrate that because I thought that was a really good point. So for example, we have 2 farmers and they want to use variable rate application. They've heard that it would be really good on their field because they both have variability. So farmer 1 has a farm size of 100 hectares and farmer 2 has a farm size of 1,000 hectares. And they both need mapping software to produce the variable rate map for that fertilizer application. So the mapping software is around $3,000 if you're going with something like SMS Pro. And then they need an applicator to actually spread that fertilizer variable rate application. And that's around $100,000. So off the bat, that's a significant amount of money to invest for a technology and a strategy that they are not entirely sure of the profitability entirely yet. So farmer one, because his farm size is 100 hectares, his cost per hectare for that investment is going to be significantly more than farmer two, whose cost per hectare is going to be around $103. And so it's going to be much more difficult for farmer one to make up that investment. It's going to take him longer at the very least than farmer two. And so if I was farmer one, I would probably not want to deal with all of that uncertainty. And that would probably be a very difficult decision to make compared to farmer two. But there are some solutions to reducing that financial burden on smaller farms. So for instance, monthly subscription payments for software, just for software in general, is becoming more of the norm. And so these software payments as subscriptions for agriculture software is also becoming more normalized, which is really great. But additionally, it would be really helpful to have monthly subscription payments for equipment as well. And this is because farmers could identify where and how the tool might fit best into their operation. And it also reduces the possibility of extreme frustration. They invest all this money into a system or a software or equipment, and it doesn't really work the way that they thought it was going to work. That can really deter them from trying to start over with something else later. And so that kind of really helps with that financial burden. Additionally, consulting government and university extension services can be really helpful in facilitating education and reducing that uncertainty. That essentially can help to identify where the software or equipment might fit into the operation, but also can really help make it more efficient and efficiently use that technology for that specific field. Additionally, industry is paying farmers to lower their emissions, and that really allows farmers to reinvest into their operation and allows them to reinvest into precision agriculture. So the second barrier that the survey indicated was a lack of trust, and I think that it really stems from a lack of communication. So for instance, we all know that the software developers of the precision agriculture tools and of decision support system as a precision agriculture tool, they're not living the same day-to-day lives as their end users, which are the farmers. And because they're not living the same day-to-day lives, this can often cause some problems of communication and miscommunication. So for example, often decisions are made between a farmer and a trusted advisor. So that would be like an agronomist, a crop advisor, an extension specialist, but it could also be somebody who's worked the field for a really long time, like a family member, and they really know how this field works. And oftentimes farmers feel like precision agriculture tools, essentially such as decision support systems, feel like a replacement for that trusted advisor. And that is kind of a disconnect and a lack of communication between the developers and the end users on kind of where they think that this technology should fit in. Additionally, machine learning, like we talked about before, especially with deep learning, is a black box. And so that makes it very difficult and very frustrating to the farmer because of the low explainability that it has. It's very difficult to really trust a machine when you can't really understand or identify exactly how it got the recommendation that it's giving you. And additionally, the paradox of acceptability is a huge issue that really boils down to a lack of communication. Essentially, the paradox of acceptability is when the developers of the precision agriculture tool or that software, that decision support system, they have a range of recommendations that they think are acceptable to the producer, and the producer has a completely different or a smaller range of acceptable recommendations. So for instance, one of these examples could be if the decision support system suggests to the farmer that they should apply water onto their field. And so that really wouldn't work for a farmer who has a dry land field and no irrigation system set up at all. And so that can be a huge breakdown of communication and a huge breakdown of trust for that tool. But there are some solutions to cultivating that trust, and it essentially is building a tool that's not just easy for the farmer to use, but also useful. And that's really just built on communication. There are some success stories such as Byte.net. Byte.net is a decision support system for European vineyard management, and they use field sensors in order to determine that data that's used in the model. And the reason why Vite.net was so successful is because they communicated with the farmer ahead of time. They talked to them about the specific issues that they have in their vineyards in order to reduce that paradox of acceptability. They were able to convey that information easily and clearly because they were on kind of the same page with the producer. They didn't live the same day-to-day life as the producer, but they were on the same page at least. So their recommendations were understandable and acceptable to the farmer. Additionally, Pigs to Win is a swine production decision support system, and they worked very closely with the farmers during their building and their design process. And a really good example of this is that when they first started building their software, they were using a completely different software system. And the farmers indicated to the developers that they all use Excel, and Excel is really easy for them to use and they're more familiar with it. And so because of that input, the developers switched their system to Excel as that base software to use, which helped the farmers to become more familiar with that system more quickly. And it also really built that trust with the system. So the third barrier that was indicated in the survey is data privacy. And the way that I like to think of data privacy is through tangibility and excludability. So let's say we have a bushel of corn. We know that this bushel of corn is tangible. An individual can pick it up, you can manipulate it physically, and a bushel of corn is also excludable. So that means that if I own a specific bushel of corn, you cannot own that bushel of corn as well. But while a bushel of corn may be tangible and excludable, farm data itself is not tangible and not excludable. And the reason for that is that the farm data is not tangible because it's data. So the only way that you can really work with it or manipulate it is through a computer screen. You can't really physically touch it. Additionally, it's not excludable. And what that means essentially is that if you have yield monitor data, for example, you put that yield monitor data into an Excel sheet and you email that Excel sheet to me. Now you have your yield monitor data and I also have your yield monitor data. So you owning that doesn't stop me from owning that. And so that's a really big problem because we need to remember that farms are a small and a large business, and they need to know who is profiting from their data and what they're doing with it. We especially need to be cognizant of the fact that machine learning is becoming more prevalent. And because of that, machine learning and machine learning models need a lot of data. And that motivates third parties to acquire and aggregate data together. And this is aggregating data from an entire region of farms. So this is a really big deal. Additionally, data ownership is similar to a credit score. So data ownership essentially is like a FICO credit score in which FICO creates that score from a lot of individual data. And they don't own that individual data, but once they take that individual data together and put it into some kind of manipulation to create that score, now they own that score. And they can sell that score back to you, and they can sell that score to other people, which might impact you financially. And it's very similar with farm data. The third party may not own that individual data in that region, but by taking that individual data, manipulating it in some way with some kind of machine learning model, now they might own that data. And that raises concerns about the power imbalance between technology corporations and the farmers when using these machine learning models. And so that's why this is so important to start to identify the laws for data ownership now before we get even more tangled up than we already are in these laws. Unfortunately, though, solutions to data privacy are really tricky, and the term ownership is really just the tip of the iceberg when it comes to finding solutions for this. There's also open source data sharing. So kind of how does it work if you upload that to a cloud or give it willingly to a third party? There's also individual contracts. So for instance, a lot of contracts will define ownership and other terms in their own contract, which it might be different than the overall broad idea of ownership for farm data. There's also trade secrets, wondering whether or not a farm data really counts as trade secrets and kind of determining that legally. There's also end user licensing agreements, and there's also landlord versus tenant. So who actually owns the data? Is it the person who is driving the combine through and getting that yield monitor data, or is it the person who owned the land that the yield was grown on? So there are a lot of really tricky things to navigate when it comes to identifying these laws. And unfortunately, these laws for data privacy and ownership are really slow to catch up with technology. Farmers are going to really need to advocate for greater protections. And I also believe that as researchers, we're always using data and we're always asking farmers if we can use their data. And so we need to also really advocate for greater protections for farm data as well. And then finally, there's workforce availability as one of the barriers that was identified in the survey. And workforce availability, that makes a lot of sense because long-term adoption really cannot be long-term adoption unless we have skilled laborers that are proficient in the precision agriculture tools, helping us to progress precision agriculture forward and also helping us when things break down. So I'm also getting this information from a 2015 survey from the Ericsson 2018 publication called Knowledge, Skills, and Abilities in Precision Agriculture Workforce. And this survey was really interesting because it identified that employees in precision agriculture are really educated. So they are meeting and exceeding education expectations for the industry. But it seems that the industry, so employers, seem to think that there is a shortage of employees that are capable of practical field applied skills and data intensive thinking. So that includes math and statistics. And this makes a lot of sense because as agriculture becomes more automated, we can kind of give that over to the machines a little bit. And humans are going to be needing skills that allow us to use that data to make decisions and use our practical field applied skills to create statistically sound experiments to create more data. And because these skills don't seem to be for employees, it seems that this is suggesting that the four-year curriculums that they are attending do not produce the employees with the skills that are needed for these practical field applied skills and for the data intensive thinking skills that industry is really looking for to progress precision agriculture. So you can see that this is a figure from Ericsson 2018, and these are the knowledge, skills, and abilities that were talked about in that survey. And you can see that there is a significant portion of each of these skills that seem to be deficient or low in their abilities. But there are solutions to training a precision agriculture workforce, and we're working towards that and progressing that every day, which is really exciting. So essentially, there is Great Plains IDEA, which is an interactive distance education alliance, and it offers fully online programs and coursework. And the Tri-Societies have partnered with Great Plains IDEA as an affiliate and they've created Ag Ideas, and they have created online courses for agriculture disciplines. And hopefully this helps to close the gap and allow for continuing education when it comes to these practical field applied skills, as well as data intensive thinking skills. Additionally, land-grant universities need to consider offering precision agriculture majors and minors that include a combination of agriculture, machinery and management, agronomy, and data science, because these are the practical field applied skills and that data intensive thinking that the students are looking for and that industry is looking for to progress precision agriculture. So essentially, decision support systems are a precision agriculture tool, and these decision support systems can use machine learning to significantly progress precision agriculture. However, we need to identify and address barriers to precision agriculture tools that we have now so that we can identify and address the barriers that decision support systems using machine learning will have in the future. And so these barriers that we just talked about include financial constraints, trust, data privacy, and workforce availability. Thank you so much, and I will answer any questions.
All right. If you have any questions, again, please put them in the Q&A section. But I'll actually start out, Sky, if you don't mind. So the way I sort of see this happening, and you can correct me if I'm wrong, the these AI models will be developed into a sort of a software package that will then go to the growers, and then they will put in their field data or whatever, and then hopefully get the model to spit out answers for what they should be doing, right?
Mm-hmm.
So what happens if if the grower doesn't have all the specific inputs that a model might require? Will these models still work under those conditions?
Yeah, that's a really good question. And honestly, as a person who is not a developer of these systems, just somebody who thinks that they're really interesting and likes to talk about them, I can't say for sure. But I do know that it's really important to have that communication between the developers and the farmers ahead of time, because I think that that is definitely something that will happen. And that's something that they need to incorporate into the system ahead of time before, that ends up being a problem in the field. So I hope that answered your question.
Indeed. Still not seeing any questions from the audience that I can tell here. So I'll jump to another question that sort of preceded here. So what are the pros and cons of using machine learning or artificial intelligence in decision support systems uh, as compared to traditional models such as process-based or empirical models?
Yeah, that's a really good question. So essentially, we're all really familiar with process-based and empirical models, and they are really powerful tools. But the thing that machine learning and AI models can do that these process-based and empirical models can't really do is that they can take in massive amounts of data. So the conventional machine learning models, they're really good at taking in massive amounts of data and have really high computing power with really advanced algorithms. But deep learning essentially is also really, really good at taking in even more data and has even higher computing power because of the way that it's set up with those hidden layers in which they're kind of mimicking the human brain, the dendrites and the synapses firing and not firing. And also, deep learning is really helpful for feature engineering. So features are those inputs that we're putting into the models, and they're kind of like the variables that we put into the model for an empirical or process-based model. And these features, sometimes we might not even know because as humans, we can only think of so many things at once. And there might be a lot of features that are irrelevant or redundant or just not going to be really good at predicting our target variable. And a lot of the time when it comes to these features, humans have to go in and pick those out and go through a whole lot of processes to figure out exactly what's irrelevant or redundant. But with deep learning, they can actually do that itself with that model, and you don't really need to go in and work on that with the model. And so that's really exciting because it can free up a lot of time, but also that's what allows these deep learning models to identify patterns that we might not be able to see from data that we give it ahead of time. So like those vegetative indices, if a human has hundreds of vegetative indices across three different points in the growing season, for example, that's going to be really difficult for us to identify what's actually going to help us predict yield. But a deep learning model can do that really well. Conventional machine learning can also do that really well, but I wanted to highlight how deep learning is also a very powerful tool.
Emily, are we getting any other questions?
Yes, so I am putting them in the chat now. If you'd
Okay.
like, I can get a start on them for you.
Sure,
Let's
please.
see. Which type of model will give the most accurate recommendation?
That's a really good question. I would say that it really depends on your field. There's definitely not a silver bullet for any of these issues. So if you have a particular problem, I think that you're going to get the best recommendation based on kind of the model that fits your system the best. So yeah, I hope that that answered the question. I think that a process-based model and empirical model are really good for things like determining nitrogen application, because that's been worked on for a really long time. And then maybe more complicated questions, the accuracy might be better when it comes to using machine learning and AI models. So it really depends is kind of how I'm trying to say that.
All right. We have quite a few questions coming in now, so I'm just going to start going down the list. Does the American Farm Bureau Transparency Evaluator help protect farmer data?
Yeah, I have heard about that. There is some things that they have done with that, and I don't really know a lot, so I don't want to speak on it too much. But yeah, I have heard about that, and I heard that it is somewhat helpful. But there are still so many things that need to be addressed that I don't think that it covers all of the things that farmers are looking for.
Okay, next question. Great talk. I was wondering if you could comment on specific strategies to address some of the key issues, specifically the trust and data ownership components.
Yeah, so trust and data ownership, that is really, really tricky, but some solutions. So for trust, one of the really big things that I want to highlight is communication between not just the developers of the precision agriculture tools and the decision support system tools, but also researchers with farmers. So developing that communication, understanding exactly what they are doing on a day-to-day basis and what they need from us will really help build that trust because then they feel like they're being heard. And that's something that is really important to building that trust. Oh, and then what was the second part of that? Sorry.
Specifically the trust and data ownership components?
Yeah, and then data ownership. Yeah, I know that there are a lot of things that are kind of getting the ball rolling here. There is, so for instance, there is the 2014 American Farm Bureau law that we talked about, and then there is the global open data for agriculture and nutrition with US and Europe. So they're kind of having conversations about that. The EU has had a code of conduct for agriculture data, trying to identify exactly how they want to deal with really complicated end user licensing agreements. But that's all I personally know about how we can kind of get the ball rolling with the data ownership. So it's a really complicated task. And like I said, just identifying a giant term of just data ownership is really not going to solve the problem here. We need people in advocating for the protections, and we need people in law who are able to provide these protections. So,
All right. How can the necessary regionalization be introduced into AI models? Ag has many parameters varying even in nearby locations and between neighboring regions.
yeah, that's a really good question. And I think that that really highlights the fact that machine learning is really important because, like you said in that question, site-specific agriculture is going to be so important for solving a lot of issues. And that's because issues in agriculture and different challenges are going to be problems that are regional and maybe even field specific. And that is where machine learning and deep learning can really excel when it comes to taking these situations. We can bring a lot of data, as much data as we possibly can, to that model, and then that model can take that information and create a model that is specific and go through that training and testing for that specific data. So that's kind of how it makes it a little bit more site-specific than a process-based or empirical model would.
All right. How does PA adoption change for small farms if local co-ops have PA capabilities?
Oh yeah, that's a really good question. Yeah, so I know that if co-ops have people who are really skilled in precision agriculture, or if they have precision agriculture tools that they can share among the co-op, I think that that's really beneficial for small farms, especially because they don't have to invest a significant amount of money into using that equipment. And that really helps to build that trust with the equipment itself too, because then they can see how that will fit best into their operation. But also, if you have somebody in the co-op who is really good with those practical field applied skills of using that equipment, as well as that data intensive thinking of now that you have used this equipment, you have all this data, what do we do with this data and how can we use this data to make decisions that will benefit you in the future? That can be extremely beneficial to especially small farms.
How important is it for both the grower and the advisor to be familiar with the same software? Will that create silos of use?
That's a really good idea. I'm not entirely sure. I think that it probably would create some specializations. So if you are really good at SMS and you don't know how to use ADMS or any other kinds of softwares at QGIS, then that really does silo you into only being able to help when it comes to SMS. And specifically, there are a lot of softwares that also are able to only use certain types of data. So that makes it kind of siloed off as well. So I would say that it's probably very important for the farmer to have similar understanding of the data and using similar software as the advisor. But I think that a lot of advisors for precision agriculture are really well versed in a lot of these softwares.
All right. Here's a good question. How many years do you suggest full curriculum training programs for precision agriculture?
I would probably say that a 4-year curriculum should really be enough as long as it combines that information. So you need that conceptual understanding. And I think that right now 4-year curriculums are really providing that really well. So the understanding of soil science, agronomy, crop science, those are really, really good right now for curriculums. But I think also we need to incorporate data intensive thinking. In Erickson 2018, he really specifies how that's really kind of overlooked. I think Fossey 2021 also talks about how that's somewhat overlooked as well, is the math and stats abilities of people that are graduating from these 4-year curriculums. And so I think that if we combine math and stats, highlighting that in curriculums, as well as what we're already doing with the concepts of agronomy and also agriculture machinery and management, and not just learning specifically how this one machine works, but an understanding of the broad understanding of these different machines and how precision agriculture tools work in general can be really helpful, not just for the farmers, but also to advance precision agriculture in general.
Okay. Next question. Do you think U.S. farmers are accepting the applications of machine learning while decision making?
That's actually a really good question, and I would refer you to a paper from Gardisi, I think it's 2020, which is kind of called Rethinking How Agriculture Data is Owned and Controlled. I can also send that to you after the webinar, and maybe you can distribute it. But this paper is really good because it talks about how the farmers are thinking about their agriculture data and using machine learning and AI. And from reading this paper, it seems that farmers are really excited about the prospect, but that it can be very difficult, especially because using this data can be a really big challenge. When you first start, it can be a really big uphill battle to really learn how to use the data in the most effective way possible. And so the farmers are really excited about it, it seems, but the entire process is kind of difficult. And so that's kind of what they're seeing.
All right. One of the big complaints about precision ag is that most of it seems to be available on a proprietary basis. What free and open source tools are available?
Yeah, there are a lot of free and open source tools available for precision agriculture. I would definitely look at QGIS. QGIS is probably one of the best systems to use for mapping that is free. And yeah, so there's QGIS, and I can't think of any more right now, but there are a lot of open source softwares that you can use as long as you just kind of look around, but definitely QGIS, I've used that a lot for things. And there's also free statistical softwares as well that you can use. So R programming software is also really powerful when it comes to using your data and kind of like learning how to efficiently manage your data and use that in a way to make decisions. So there are a lot of systems out there. You just kind of have to look for them. Sorry, I can't think of more right now.
Okay, most research is done on small scale plots, such as variety trails. How much useful is the data collected from research plots for model training and validation?
Yeah, I would say that probably there are pros and cons, of course, to using smaller plots when it comes to research compared to larger field trials. And I think that's definitely why, as researchers, we always try to start with our small plots and then move into larger field application strategies to kind of see what the differences are there. So I would say that there are pros because we can kind of learn and really manage that particular area and understand the variability that comes with that. And then we can expand, and that also is a really big pro for understanding how that system works on a larger scale. So,
Okay, is machine or deep learning being used by these agricultural tech providers like My John Deere, et cetera? Do they teach their specific system to PA employees? Are you able to answer that one?
I don't know if I can really answer exactly what John Deere is doing, but I don't know if machine learning and deep learning right now is super prevalent in these different systems. I think that it's becoming something that people are considering more, and it will become more prevalent in the future.
Good. Can you elaborate on farmer data ownership with respect to academic research? Do you foresee any constraints?
Yeah, I know that definitely farmers are concerned about giving their data to third parties. And I mean, researchers, we are still a third party that they have to kind of weigh the pros and cons of whether or not they want to give us their data. Um, and so, yeah, does that answer the question? Can you repeat the question maybe?
Sure,
Sorry,
let me go back up to it. Um,
too many questions.
it's a lot. Can you elaborate on farmer data ownership with respect to academic research? Do you see any constraints there?
Oh, yeah, definitely. I would say one of the constraints is just that trust and building that relationship with the farmer. If we don't have the farmer's trust when we're asking for that data in an academic sense, they're definitely not going to give that to us and they're not going to work with us. So I would say that that's definitely a constraint.
Okay. This user has two questions. One, is there a scale threshold required for the grower to support a DSS model's costs?
Okay, so a threshold to support the cost of the decision support system?
Mm-hmm.
Okay. I'm not really sure about that. That would probably be something that the developers would be able to kind of determine with the farmer. But I think that there should be a way for smaller farmers to be able to use these systems, especially because, like I was talking about before, if there are financial constraints and it is not really a lack of variability in the field, this could prevent the smaller farms from using these systems. And if we're not using these systems, they're not collecting data on these systems. And so the future machine learning and AI models that use these same models and use this data are going to be really biased toward larger farms. And so that's definitely something that we need to keep in mind when it comes to this.
Okay, and the second question from this user, hackers are so creative. Do you happen to know if a DSS database can be kept reliably secure?
I don't know if it can be kept reliably secure. There are so many breaches in security of things that are just already really like supposed to be really secure, and that are have been here for a really long time. So some new technology, I'm not entirely sure. I wish I could tell you that it would be, but I don't know.
Just never know in this day and age. Um, is there a specific PA textbook that you would recommend for a beginning PA course?
Yeah, I know that the Precision Agriculture Basics book is really good. I think that it was the best-selling book for a really long time among the societies. It was published in 2018, and there is actually a revision being done for that book now. So please keep an eye out for that because I think that will be really helpful for precision agriculture education.
Okay. We're starting to wrap up. Do you consider the industry to have had more difficult, oh, wait, pardon, let me start over. Do you consider the industry to have made it more difficult for universities to get trust from farmers, creating a research gap between industry and universities?
I
Oh,
would say
there's,
maybe,
go ahead.
possibly. I'm still really new to research in general. I've only kind of been doing academic research for 3 years now. So I don't really have that experience to know exactly if the industry has really changed things with farmers' attitudes towards providing data. I can see from reading and kind of looking through the literature that it does seem that that has caused some rift between the researchers asking for data from the farmers because it is similar to just another third party asking for data. And so that is why communication and trust is so important when it comes to asking for that data and like building that rapport with the farmers.
Okay, next question. What is your take on which is better, precision agricultural practices versus traditional practices for climate smart agriculture?
I think that they are not really separate things. I think that you can really use them together and they benefit each other significantly. I don't think that you can really do climate smart agriculture at this point without using some form of precision agriculture tools. Um, so yeah, I don't think that they're really separate things. I think that they really go hand in hand with each other.
Okay, and I have one more here. Do you think there is a farmer-friendly tool which can help him in doing an advanced machine learning approach, rather?
Okay. I don't know off the top of my head, and I think that machine learning and deep learning in agriculture are still relatively new. So I don't think that there is something right now that you can go to really learn as like it's like a decision support system with machine learning, right? To like learn how to do that. Yeah, I don't think that there's anything right now. I know that there is a lot on the internet that you can learn about machine learning and deep learning to kind of build up your knowledge base. But right now, I don't think that there is anything that you can go to.
Okay, and I'm going to grab one more. This is kind of a long one. You talked about the importance of collaborating with farmers while developing DSS and DSTs to improve farmers' trust and use of the tools. Do you see researchers and modelers being receptive to this idea? It seems like the concept was not mentioned, but industry as an area of improvement. But do you think this should be part of the PA courses and training that you had mentioned?
Definitely, because I think that a lot of people who are going into precision agriculture, a lot of them are going into industry. And I think that that is a really big point in which precision agriculture will progress. And so I would just say that if industry and developers in industry want to make money, they probably should be working really closely with the farmers because if your system is not something that is going to be adopted for long term, you might make those profits initially, but then they're going to disappear after a while. So yeah, I think that that's definitely something that's important, and curriculum should definitely talk about that. There should definitely be a huge aspect on how industry should go about helping to progress precision agriculture.
Okay, and I have one more question coming in. I think this is the final one. Do you know if there is any development of laws relating to DSS or precision ag?
I don't know off the top of my head right now. I know that there are some laws and different things that are getting the ball rolling when it comes to talking about data ownership and privacy, but not specific to machine learning and decision support systems. But I'm sure that there are some things that I just don't know about. So I'm sure that there are things, and if you look around, you might find some things because this machine learning and AI technology has become really prevalent, a huge talking point in the past year or so. So I'm sure that there is something.
Okay, that looks like all the questions we have. So I'm going to go ahead and wrap things up. I want to thank everyone again for joining us for today's webinar. I want to thank Sky for sharing your research and to Dr. Horvath as well for moderating the discussion today. We hope you found the topic interesting and encourage you to view our special section on machine learning and precision agriculture, which can be found in the latest issue of Agronomy Journal. As a reminder, the recording will be made available and sent to all attendees soon. We also encourage you to fill out the short survey after the webinar concludes. Thank you again and have a good day, everyone.
Thank you.
Thank you.